In this video, we're going to talk about the idea of ownership. So far, we've seen several different types of objects that are able to give access to an underlying variable. First, while learning about containers, you learned about iterators, which we described as a view into a particular entry into a container. Last week, you learned about references and pointers, which let you pass around an object itself instead of a copy of the object. And in the last video, you learned about smart pointers. If you're not clear on any of these topics, I would highly recommend that you go back and watch the videos again. I'll be referencing them quite a few times throughout this video as examples. With that disclaimer out of the way, let's review the difference between pass by reference, or pass by pointer, and the idea of pass by value. So if you recall, when you pass a value, say a vector, into a function, it creates a new copy of the variable. That means that if you edit it inside of the function, it's completely separate from main's copy in this case. So SumFunc has a copy, and main has a copy. Contrast this with the idea of pass by reference, which allows you to reference a variable from some other scope. That variable still belongs to main. Primes is still main's version of primes. It's just that you're accessing it in SumFunc. The same situation applies with pass by pointer. Now let's say that you wanted to make a function that stores a pointer for later use. For example, say you've got an object, and it might want to store a pointer to some other object that's passed in through a function. But what if you make a local variable and pass a pointer to that variable into the object? Well, the local variable x isn't going to live long enough. Its lifetime is going to end before the lifetime of the object ends, potentially. This isn't a good situation. But it can also be sort of difficult to think of things just in terms of lifetime. And that's why we bring in the idea of ownership. In general, the idea of ownership is just simply that each object's lifetime is controlled by the lifetime of its owners. In C++, resources should last for as long as they're needed by the owner and then be destroyed. It's often useful to share a resource with code that doesn't have ownership over that resource. This can be thought of as lending out ownership. The temporary user should only hang on to the resource for as long as it needs to, and it isn't responsible for destroying the object. So it needs to make sure that it doesn't use the object after the owner is done with it. Again, this model corresponds with the idea that you shouldn't use a resource after its lifetime is over. It's just another mental model you can use to think about it. Every object has at least one owner for the duration of its lifetime, and it should never be alive when it has no owners. For almost all objects, at least one means exactly one. You'll only ever have one owner at a time. The one exception here is shared pointer, which obviously will have multiple owners. Each shared pointer is a particular owner of the underlying object. In this case, the object's lifetime only ends when the last owner loses access, or when the last shared pointer goes out of scope. The original owner of an object is the code, the function or class, that created it. For the purposes of determining ownership, copying an object, like passing it into a function by value, is considered as creating an entirely new object. From there, ownership can be transferred from one piece of code to the next. Returning an object from a function always transfers ownership. For example, if you have a function that returns a unique pointer, it will not create a new copy. The old copy will immediately be destroyed anyway, so the compiler transfer ownership of the object to the receiver of the function value. In other cases, you can transfer ownership with stdmove. We'll look a little bit more at that later, but suffice it to say for now that this is just a way of telling the compiler to explicitly transfer ownership. Let's look at an example. You can see that we've got a function that creates a unique pointer and then transfers ownership over back to the caller. So here, we call getUnique, we create the pointer. At this point, we're returning, so instead of the new unique pointer going out of scope, it just gets transferred to the new function. Now main is the owner of pointer, and we can use it. And finally, when main ends, that pointer will go out of scope and be deleted. Now let's take a quick look at some of all of the types that we've seen so far, and just think about whether or not each one is owning or non-owning. So if you recall, owning are things where time of this handle ends, the underlying object will be destroyed. In contrast, non-owning is when this doesn't really have any bearing on the lifetime of the object, and you have to make sure that it won't outlive it. So I'd recommend that you just pause the video and try to figure out whether each of these types of objects is owning or non-owning, just to make sure that your mental model matches up with what's really true. I'll give you a couple seconds. Okay, so hopefully you've gone through the list by now. We'll start off with an easy one because I've been using it as an idea or as a canonical example throughout this entire video. Unique pointer is definitely owning, right? As soon as the unique pointer is destroyed, the object that it references is destroyed as well. Now, references are, again, not owning, right? They only give you a temporary lease on an object. You can only have temporary access. Now, shared pointer is one of the special cases, right? It's owning, but it's owned by multiple owners. So you have to, so the shared pointer is automatically able to figure out when it has any non-zero amount of owners and not delete it until it has no owners. T is in fact owning, just a standard value type that's on the stack, for example an integer, that goes out of scope and it's destroyed, so that's an owning type. Pointers are very similar to references in that they are non-owning. And finally, iterators are just a view into the container. They don't actually create a copy of the object, it's just a way of accessing something that is owned by the container itself, so we say that they are not owning. Hopefully this gave you a better idea of what owning and non-owning means. We'll probably go over it in class because this is a bit of a tricky concept, but for now that's all for this week.